Simplify. We have a fraction on the top. We have x to the negative 5 power plus y to the negative 5 power. And on the bottom we have x to the negative 1 power plus y to the negative 1 power. Okay, so we need to know something about negative exponents. The rule we would need is x to the negative n is the same as 1 divided by x to the n. Okay, so this first x to the minus 5, locally we're going to change it to 1 over x to the 5th. Do not drop this all the way to the denominator of this fraction. That's not allowed because this plus sign means that this is just a term. And this rule only works within the factor, within the term that it is. Within the term that it is. This is only its own term. It's not a term of the entire expression. That might be confusing. But one thing you can do, if you circle the base and the exponent, you can only do this rule within that circle. So we have 1 over y to the 5th on top. On the bottom we have 1 over x plus 1 over y. But we have now rewritten this from negative exponents to a complex fraction form, where the numerator has fractions and the denominator also has fractions. One of the quickest ways to reduce this is to determine what is the lowest common denominator of all of the little mini fraction denominators. And I see x to the 5th, y to the 5th as being a common denominator. So if I multiply the first term by x to the 5th, y to the 5th, the second term on the top by x to the 5th, y to the 5th, the first term on the bottom by x to the 5th, y to the 5th, and the second term on the bottom by x to the 5th, y to the 5th. This will allow me to reduce all the little mini fractions. Notice it has to be the same thing that I multiply on all the terms on top and bottom. If it isn't, we're weighing either one term or the numerator denominator differently, and this will not be an equivalent expression. Also notice that I am multiplying by these terms, so don't put them in the denominator of these mini fractions. Now one at a time, each fraction is going to reduce. So we're left with first term y to the 5th plus the second one, the y to the 5th reduces, leaving plus x to the 5th. That's the numerator. Denominator, 1x reduces, leaving us an x to the 4th, y to the 5th, plus, and the last term, 1y reduces, leaving us an x to the 5th, y to the 4th. Now if we wanted to try to simplify further, since these are all individual terms, terms don't cancel. We couldn't try to reduce the y to the 5th or anything like that. We could try to factor, but this is a sum of fifths, no greatest common factor. It doesn't factor, so we can't even factor it. This, in fact, is the most simplified final answer. Some people might take a look at the original expression and see that that maybe is a little more simple, but it's simple in a kind of a confusing way with the negative exponents. It doesn't look like it behaves. This is a little more straightforward, although it takes some steps to get there. This is what you'd be expected when they say to simplify this type of expression. I hope this helps.